Law of relative velocities works if you have a boat, river, and shore. The velocity of the boat relative to the ground is equal to the velocity of the boat relative to water or river plus velocity of the river relative to ground. Could have been velocity of river relative to the boat equal to velocity of a river relative to ground plus velocity of the ground relative to the boat. It doesn't really matter how you call them, 1, 2, 3. The equation always works, but it's just the most convenient way to write it down. The rest is geometry. Now we need a lake first, then I make it into a river. What is the difference between a lake and a river? In a lake, the water is still, it has no velocity, it's not moving. In a river, it does. So in a lake, let's say I aim my cart this way. So it travels in this direction, but relative to the lake and relative to the ground, the velocity is the same, distance traveled is the same, displacement is the same. What's going to happen if it's a river? Well, let's say water goes that way. So if the stream is really, really fast, it reaches the opposite shore somewhere else. This will be the actual displacement of this boat relative to the ground, relative to the person looking from the ground. Where's this? This is the observer. That's what that observer sees. I want my boat get right here, right across, shortest path. That only can happen if velocity, this velocity, that velocity, and angle have a specific match. Yeah? Like this. And because they have to match, there is a mathematical relationship we can use to relate those and solve for everything. Now, this is the shortest path, you see, aiming up the stream, a certain angle, in order to compensate the drag by the water. What's going to happen if I would aim right across? That's aiming. In this situation, the stream would drag it down the stream and it would land somewhere else, here. So this would have been actual displacement relative to the ground now. So we have to keep these pictures in mind. You should aim your boat a certain way, so you want to get right across the river. Two shores, you start here, right? This is an arrow that represents the velocity of, let's say, water relative to ground. So there is a person right here under the tree. Relative to the ground means as viewed by that guy. And as viewed by that guy means that this boat travels right at that guy and ends there. This arrow should represent the displacement of the boat relative to the ground. That's what he sees. But how should we aim it? We should aim a boat upstream. With no river in a lake, it would hit this point. Because of the stream in a river, it always remains on this line. So this velocity of the boat, well, relative to what now? First of all, it cannot be relative to ground, because this is supposed to be relative to the ground, velocity of the boat relative to the ground, because it equals to displacement of the boat relative to the ground divided by the time. So what letter should I add to this velocity? Water. This is the velocity of the boat relative to water. That's how it would travel in a still water, in a lake. And the velocity of the boat relative to ground is equal to velocity of the boat relative to water plus velocity of water relative to ground. That's a law of relative velocities. This is how these arrows are supposed to be related, and they are related like that. Yeah? We can just look at arrows, oh, wrong, the velocity of the boat relative to the ground is represented by this arrow, boat relative to water, water relative to the ground. We can see that, of course, they form a triangle. A tail to a head rule, the velocity of the boat relative to water plus velocity of water relative to ground gives velocity of the boat relative to the ground. Well, we don't need vectors, we need just a standard triangle. In this triangle, we just have to now write numbers correctly. Current, this is this, 3 meters per second. In a lake, means relative to water, this is this, 5 meters per second. And this is the angle, how to aim it, let's say theta. And this is now the speed of the boat relative to ground. And physics is, no, over. We have to make a transition from physics to vectors to geometry. If we do it right, the rest is writing equations and plugging in numbers, Pythagorean theorem, angle, etc.